Hello, my thoughtful teenagers, and welcome back to another episode of Grade 10 Math with me, Miss Lambert. For today's lesson, we are still on linear inequations, but for today, we're going to be looking at how we solve worded problems. Let's get right into the lesson for today. Let's jump into our example straight away. Now, it says here, and you can read with me, the area of a rectangle must not be more than 126 centimeters square. If the length of the rectangle is 18 centimeters, calculate the greatest possible value of its width. Now let's go this again. I want us to go through the worded problem again. So you're going to be able to identify what you're solving and what you need to do. Let's go again. Read with me. The area of a rectangle must not be more than 126 centimeters square. If the length of the rectangle is 18 centimeters, calculate the greatest possible value of its width. So the problem says the area of a rectangle must not be more than 126 centimeters square. If the length of the rectangle is 18 centimeters, calculate the greatest possible value of its width. Now, as you read inequality problem, you want to write down the information that is given. So the first information that was given is the area. So the area is equal to 126 centimeters square because area is always measured in squared units. And the length is 18 centimeters. But what is the formula used to calculate area of a rectangle? So it's A is equal to L multiplied by B. But in this case, it says that our area must not be more than 126 centimeters square. So if it's not more than, it definitely is less than. So we need to rewrite this. So A is less than or equal to LB. Now we can substitute. We know A is 126, and that is less than or equal to L, which is 18 multiplied by B. From here, we can further simplify. So we divide both sides by 18, and you are going to see that 7 is less than or equal to B, which is your breadth, or in this case, the width, the greatest possible value of the width. Yet another example. Read with me. The area of a triangle must be more than 108 centimeters square. If the length of the base of that triangle is 12 centimeters, determine the greatest possible value of its altitude. So right away, we know that we're working with what shape? Yes, we're working with the triangle. And how do we calculate the area of a triangle? And if you would have guessed that we use half of base multiplied by height, you are correct. Additionally, the other example said, the area of a rectangle must not be more than 108 centimeters square. So we already know from that our area is 108 centimeters square. Let's continue reading. If the length of the base of the triangle is 12 centimeters, so our base is 12 centimeters, determine the greatest possible value of its altitude. And our altitude is also known as the height. So first, let's write the formula. So area of a triangle is half BA, or half of the base times the height. Now remember, we are dealing with inequality. So it says that the area must not be more than. So it is definitely less than. So A is less than or equal to a half of B multiplied by H. So now we can plug in our values and solve. So our area was given as 108, and that is less than or equal to a half of the base, which is 12, multiplied by the height. So if we are to simplify this, we're going to have 108 is less than or equal to 6h. We divide by 6 because we want to find the value of h. And when we do that, we are going to see that 18 is less than or equal to the height. And there you would have solved yet another worded inequation. Let's continue. Here we have yet another example. Let's read. The width of a rectangular room is 5 meters shorter than its length. If its perimeter must not exceed 38 meters, determine the greatest length the room can have. Now, when you have a problem like this, you will take a different approach towards solving. How do we do that? First, we represent the information given on a diagram. Now, the other example said, the width of a rectangular room is 5 meters shorter than its length. If its perimeter must not exceed 38 meters, determine the greatest length the room can have. So first, we want to have a representation of this room. So let's draw a little rectangle to represent this room. So there we have our room. We know that the length is L, but the width is 5 meters shorter. But in this case, we're focusing on the perimeter, and the perimeter is the total distance around. So when we sum all of the elements around this, it must not exceed 38 meters. So it must be less than or equal to 38 meters. So let's rewrite this in order to have an inequation that we can solve. So I'm going to sum L plus L plus L minus 5 plus L minus 5. Because when I sum all of this, I am going to have my perimeter. So I can further simplify this by putting all of my like terms together. So I put all of my like terms, first beginning with my algebraic term, which is L. So I have L plus L plus L plus L. Then I work with my constant value. I have my constant values to be -5 and -5, which is equal to my perimeter. So when I simplify this, I will have an equation in L that I can then use to solve. So when I simplify that, I will have 4L minus 10 is equal to my perimeter. But I do not want it to be equal. I want it to be no more than a figure. But I know that figure already. So I can rewrite all of this as an inequality, taking into consideration my information that was given. So now I have 4L minus 10 is less than or equal to 38. And here we have a linear inequation that you can go ahead and solve using the same rules as if you were solving a regular equation. So first we take over, or we add 10 to both sides. So we have 4L is less than or equal to 38 plus 10. When we simplify that, we're going to have 4L is less than or equal to 48. And we divide by 4 because we're finding the value for L. So therefore, L is less than or equal to 12. And there you would have once again solved another linear inequation. Please remember to write your statement. Hence, solution set equal to L such that L is less than or equal to 12. And you do that for all inequality problems. So you just do not write your answer or leave it the way it is. You must write your statement. Now, we would have come to the end of our lesson on solving inequalities worded problem. Let's recap what we covered in this lesson. Now, first, you must read the problem and write an equation that is needed. Once you would have done that, you rewrite the equation as an inequality. Then, when you're solving linear inequalities with one unknown, which will be the case in worded problem, all the rules that are applied to linear equation are observed. Remember, your answer is given as a set. So please remember to always write your answer given as a set. So there you have it, my thoughtful teenagers. Our lesson on solving inequalities worded problem. Remember, I want you to be able to solve these problems without the hassle. How do you do that? Yes, you practice, practice, practice. I am Miss Lambert, thanking you for being here with me on this episode of Grade 10 Math. And remember, do stay safe, and I will see you next term. Bye bye.